So this is the cultivation strip in the AHDB potatoes, strategic potato farm. What we've been looking at here is a number of primary cultivations and secondary cultivations in combination with each other and on their own, as part of a continuation of AHDB sponsored potato work at Cambridge University Farm. I'm here with James Dorr, who's the farmer who's kindly agreed to manage the experiments and demonstration strips. And where we are standing now is just the beginning of the secondary cultivation strips. So James, we had to set up some controlled primary strips in here. I just wondered if you could explain the background to the treatments that we discussed ourselves and what actually came about as the order and the timing that we put them in.
Okay, we had a bit of a setback a few weeks ago when we had 37 millimetres of rain, which sort of really damped it, and that was following some stubble turnips where we had some lambs grazing over the winter, which we've done many times on this block of land before, but this time it really stayed very, very damp underneath, and we had to sort of change the strategy to what we found here. So we subsurface cultivated only to the depth of 150 mil to let a drying process begin, and then we run through a bit deeper a second time, followed by the plough. We left a patch here up the middle of 24 beds to do at different depths. So what did you find, Mark?
Well, the sort of hypothesis behind this is trying to understand a bit more about why growers cultivate soil so intensively for potatoes. Largely for the packing trade, where we want very fine soils to avoid damaging diseases like common scab, where the finer soil is very important. However, the findings over the past 3 years of the AHDB potatoes sponsored work is that we can come appreciably shallower and actually maintain yield and quality and also harvest potatoes. So what we've been doing here on basically a best practice farm is to actually look at the treatments that growers would use across this sort of soil type over the country and look at our sort of best practice, i.e. minimal or reduced cultivation strategies. So the series of treatments we've got here are a range of commercial practice and shallower and deeper than that to actually understand what's going on in terms of the practice of growing potatoes, the yield, the quality, and actually how much it costs to actually cultivate the soil. So we're looking at fuel costs, speed of work rate, and wear and tear on machinery. And that's all going to be put together as part of a demonstration practice. What we're in now is actually the deep treatment. So I'm expecting this to be somewhere between 55 and 60 centimetres deep, from the top of the bed to the furrow. So if we actually measure it down, we're getting 55 centimetres from the top of the bed. So I would regard that as being deep in the terminology of shallow, medium and deep. What we're going to do now is go to the commercial depth, which is the medium depth. So here we are in the commercial depth bed forming. Again, taking from the top of the ridge, we've got 45 centimetres as settled soil. We're now moving into the shallow treatment, and in here in this particular position we've got 36 centimetres. Now that's much shallower than most people would have on this particular soil, and whilst most people seem to be fixated about the depth within their de-stone beds prior to planting, it's been raised that how many people actually do measure the heights of the top of their beds to get a consistent depth for the de-stoning. So in general principles, if we're going to de-stone deeply, we need deeper beds. And if we come appreciably shallower, then our bed height should consequently become shallower as well. Now initially we set up two contrasting cultivation regimes. Initially our programme was to start with non-inversion tillage across the whole field, but in view of the slow drying in late April, the grower James Dorr decided to actually plough the majority of the field, which left us with two 24-metre strips where we ploughed slightly shallower than the standard depth, and then also put in a 24-metre strip of non-inversion tillage cultivated by the Simba SL. So we've got those running at right angles to the rest of the secondary cultivations, and in summary, the primary cultivations have shown no effect on yield or tuber grading or the size distribution of tubers in the processing grade of Innovator. An anecdotal piece of evidence was, when I was sitting on the tractor, was an increase in fuel usage and a slowing of the operation when we passed over the min-till operations compared with the plough. Just anecdotal evidence, but an observation. So moving on to bed forming, which is the first of our secondary cultivations, basically what we found was that in standard, that as we went shallower, the fuel usage and the speed increased. If we compare shallow versus standard, we're about 32% faster in terms of our forward speed. That equates to about 23% cheaper, by about 17 pence a tonne, than the standard treatment, which would work out about 22 pence a tonne if we include labour and fuel costs. As we went deeper, i.e. much below the commercial depth, the rate of fuel use and the cost in terms of labour through the slower operation actually doubled. So we can see there's a massive improvement from coming shallower. Interestingly, from the GPS measurements and actually the forward speed that's related to the wheels, we actually found differential wheel slip. With the shallow bed forming, it was only 9%, standard a little bit more at 13%, but a massive increase to 28% where we were deep bed forming. Now interestingly, fewer clods were actually produced during bed forming the shallower we came. So that's an indication that deep bed forming is a thing that actually gives us an increase in clod content we've then got to subsequently deal with thereafter. So if we move on to the next stage of the operation, whether or not we bed till, it was decided that the majority of the field, given the wet conditions, would be bed tilled, is that we compared the fuel and rate of work of a very intensive operation. Not surprisingly, deep bed filling was very, very costly in terms of fuel. About £34 a hectare versus the shallow, which was around about £13 a hectare. Shallow bed forming and bed tilling were about 48% faster than the standard depth used by the commercial grower. So again, we're nearly twice as fast. Deep bellied tilling was not effective in reducing the proportion of clods in the field, and that's very crucial, that actually what we're trying to do with bed tilling is to break the clods down and improve our forward speed. But actually that didn't happen at any of the depths where we did standard or shallow, i.e. the best practice. The rate of work was not improved by bed tilling. The only rate of improvement we got from bed tilling was when we deep bed formed and deep destoned. So that's quite interesting as an set of observations. So obviously the third operation is destoning. We've followed the two previous operations, and it certainly is the most costly and slow of all the operations that we're conducting as part of our secondary suite of cultivations. Shallow destoning, which as we've found in previous work over the last 4 years, was about 43% faster than the standard rate used by the commercial system in the field. And with adding together fuel and labour, it saved about 32% of the costs compared to the standard system. Now, that's all very well saving costs and improving speed, but did we maintain the yield and actual grading? In summary, yes, as been proven by previous experiments, the yield didn't differ over shallow, standard and deep cultivations in terms of destoning. Where we gained was improvement in actual forward speed and rate of work, and in difficult seasons that would be the thing that would possibly gain you more yield in terms of the timeliness of matching the cultivation window to your capacity of machinery. The deeper we bed tilled, the lower the yield, and so actually avoiding bed tilling gave us adequate seed beds, a reduced cost of eliminating an operation, and actually an improved yield. So in summary, the effect of primary cultivations, little effect to compare between shallow and deep ploughing and non-inversion tillage. When we looked at bed forming, certainly shallower gave us adequate soil to destone and form beds, with a saving in cost and improvement in speed. Actually, with bed tilling, that's the most interesting part of the study. That crucially, we found that bed tillers are often used to improve the rates of work of destoning. And what we found here, it's only at very deep depths that we're finding that that situation applies. And at standard depths and shallower, we can actually get away with either not bed tilling or certainly tilling a much shallower than current practice.